In the 1940s, two men would walk the quiet paths of Princeton, deep in thought. One of them was Albert Einstein. The other, a quiet, mysterious logician named Kurt Gödel. While Einstein tried to unlock the secrets of the physical universe, Gödel was asking a different question. Could God's existence be proven with pure mathematics?
Meet Gödel. You may have heard of Gödel's incompleteness theorem, the groundbreaking idea that shook mathematics to its core. It says no logical system can prove all truths within itself. In other words, some truths exist that can never be proven. This paradox was radical, even terrifying to the world of logic. But there's a deeper, lesser-known side of Gödel's mind. He believed math could reveal not just numbers, but ultimate reality. The secret proof. Quietly, in the final years of his life, Gödel wrote something extraordinary. A formal, symbolic proof, not for a math equation, but for God. That's right. Gödel believed he could logically prove the necessary existence of a supreme being. But he kept it hidden. For nearly 30 years, he told almost no one. Not because it was weak, but because he feared it would be misunderstood. Disclaimer, it's not religion. Before we go further, this isn't about religion. Gödel wasn't preaching. His argument is a mathematical and philosophical model grounded in logic and ontology, the study of existence. You don't have to be religious to follow it. But if it holds up, it challenges how we think about God, truth, and proof itself. Logic is the root of math. Gödel, like all great mathematicians, studied logic deeply. In fact, math is built on logic, axioms, theorems, deduction. And just like in geometry, where certain truths are accepted without proof, Gödel starts his argument with axioms, basic assumptions. From there, he builds a chain of reasoning toward a surprising conclusion. A priori versus a posteriori truths. To understand Gödel's logic, we need to step into philosophy for a moment. There are two kinds of knowledge: a posteriori, knowledge from experience, like physics, and a priori truths we know without needing observation, like 2 + 2 = 4. Gödel's argument falls into the a priori category, and so do some of the deepest truths in logic, like a thing cannot be true and false at the same time. Necessary versus contingent existence. Now here's where things get interesting. In logic, there's a difference between contingent existence, things that exist but don't have to, like you and me or this video. Necessary existence, something that must exist in all possible worlds. Gödel's bold idea that God, if defined as the sum of all positive attributes, would be a being whose existence is necessary, not optional, not possible, but required. The symbols behind the proof. Gödel's actual proof is written in modal logic, using symbols and variables. It looks more like an equation than a prior. But at its core, it's built from a few key ideas: that positive properties exist, that a being possessing all of them must also possess the property of existence, and that existence itself is a positive property. From this, he builds a logical framework where the existence of such a being, God, is logically necessary. Why he hid it. So why didn't Gödel publish this proof immediately? He feared it would be reduced to religious debate. Or worse, that people would weaponize it for ideology. Gödel wasn't interested in arguing for religion. He was searching for logical perfection, a truth that holds even in silence. Criticism and open questions. Critics have pointed out flaws, questioning the meaning of positive or whether existence is a property at all. Others argue logic can't escape assumptions. Still, Gödel's proof sparked a wave of exploration in theology, AI, and metaphysics. Even computer scientists have tested the proof and found it logically consistent. But philosophical questions remain. Is a logical God the same as a living one? Can we define divinity into existence? What do we actually know? Maybe Gödel's real message wasn't to prove God to you, but to show that even in the coldest logic, there's room for the ultimate questions. That maybe, just maybe, not everything that's real needs to be seen, and not everything that's seen is truly understood. So, what do you think? Is Gödel's proof meaningful or just mathematical poetry? Drop your thoughts in the comments. And if this got your brain turning, like, subscribe, and join us for more stories that challenge what you think you know. This is You Should Know.